In part B of lesson 1.8, we're going to be using the quadratic formula again, and you're going to be able to solve a quadratic equation using that formula, and you're also going to be able to apply the quadratic formula to solve a real-world problem. Let's go ahead and get started by taking a look at the example 1, which is just a recall that we can use the quadratic formula type problem. And so in order to get started with this, we want to make sure that one side of the equation is equal to 0. So you see the 56 on the right, we need to get that over to the left. So 2x squared minus 6x, and if I subtract 56 on the right, I also have to subtract it on the left. So now, this is what my equation looks like, and I need to identify the values of a, b, and c. Well, a is the one in front of x squared, so a is going to equal 2. B is the one in front of the x, and so b is going to equal negative 6. And c is going to be negative 56. Step 3. Substitute the values of a, b, and c into the quadratic formula and simplify. All right, let's go ahead and do that. So we see our quadratic formula here, and I'm going to take the opposite value of b, which is just going to be 6 in our case, plus or minus, and I am going to square b, so that's going to be 36, positive 36, minus 4 times my a value times my c value, and all of that is going to go over 2 times 2 because a is 2 in this case. So if I simplify that, I'm going to end up with x equals 6 plus or minus the square root of 484 after you get done with all that condensing under the radical symbol, and that's going to be over 4. Now if I take the square root of 484, the square root of 484 is 22. So when I get ready to really simplify, I'm going to have 6 plus or minus 22 over 4. Now that gives me that x is equal to 6 plus 22 over 4, or x is equal to 6 minus 22 over 4. Remember, this plus or minus right here helps us generate two answers for x. So if I simplify this, 6 plus 22 is 28, and x equals 28 divided by 4, which is 7. So there's one of my answers. And if I simplify 6 minus 22, that's negative 16. So negative 16 divided by 4, x is going to equal negative 4. Okay, so I have two answers for x, the x equals 7 answer and also the x equals negative 4 answer. So that's just a reminder of how the quadratic formula works to help us solve a quadratic equation. Now here's a little table that kind of shows you when should you use which method, okay? When should we use square roots? Well, there's a couple of times where you're going to use this. It's going to be where you do not have a b value, okay? That's one of the places that you're going to want to use it, or if you have something in vertex form. So let me give you an example of a time where there is no b value. So for instance, if you have something that looks like this, y equals 5x squared minus 25. Okay, so there's nothing there that has just an x term, so therefore there's no b. And that's when you would use the square roots method. You would also use the square roots method if you had something that looks like this, where it's in the vertex form. Okay, so there's a hint for you. And then when would you be using factoring? Factoring means when are you going to be looking for two binomials that you can multiply together, or when would you be undoing the FOIL method? Undoing, foiling is really what factoring is all about. Okay, so here's an example. If you have something in standard form when a is 1, okay, when there's not a number other than 1 in front of there, and you are sure that there are two factors of c that sum to b. So let's take a look at an example of that. So if you have an equation in standard form like this, x squared plus 5x plus 6, we know that we can factor this because two numbers, 2 times 3 equals 6, and 2 plus 3 equals 5. Remember, we're looking for two values that sum to 5, but multiply to 6. So we would have to say 2 and 3. So you can use the factoring method. You don't have to use the quadratic formula when you can find values that actually multiply to C but sum to B. Okay, and when can we use completing the square? When do we have to take half of B and square that and then add it to both sides? Well, it's when A is equal to 1 and there are not factors of C that sum to B. So let me give you a couple of examples of that. So let's say that we have this equation. Y equals x squared plus 10x plus 13. Can you think of two numbers that multiply to 13 that also sum to 10? No, you cannot. So that's when you would want to use completing the square. Here's another example of an equation that does not have any numbers that come out nice and neat for the factoring. Okay, can you think of any two numbers that multiply to 21 that also sum to -5? Well, factors of 21 are 7 and 3, and neither one of those would sum, or if you add them together, they don't sum to -5, so that's when you would want to use completing the square. And for the quadratic formula, you would want to use the quadratic formula when a does not equal 1. Okay, a does not equal 1 means that there's a value there in front of the x squared that is something other than 1. So for example, 3x squared minus 4x plus 5. Okay, or if a, b, and c are decimal values, you definitely don't want to try to deal with using completing the square or factoring or square roots if you have decimal values. So it's going to be easier to just use the quadratic formula if you have something that looks like this: 1/2 x squared plus 3.7x. Okay, so if you have some strange a, b, and c values, and when a is not 1, then you want to use the quadratic formula. I hope this is a little bit helpful. In class, I'm going to be giving you a flow chart that kind of says the exact same thing to help you figure out what is the fastest method and most useful method to solve each type of quadratic equation. And we are on page 2 here to look at example 2. I'd like you to do problems B and D on your own, so I'm going to have you do these two. You need to pick the appropriate way to solve each quadratic equation. So looking back to the front side of the paper, which method would work best for this problem right here? We do not have a b. B is equal to 0. And I believe when b is equal to 0, we want to use the square roots method. So we're going to use the square roots method because we don't have a b. And so we're not going to use the quadratic equation, although you remember a quadratic equation for sure works for any of these problems, but it's probably easier to just try it this way. So 4x squared equals -2 because I want my 4x term by itself initially. Now I want to get rid of the 4 because I want x squared by itself. So I'm going to have x squared equals -1/2. And if I take the square root of both sides, then I'm going to end up with x equals, and remember, when we have a negative underneath that radical symbol, we need to say that that is an I. So the factoring of -1/2 is actually I times the square root of 1/2. Now we could turn that into a decimal. 1/2 could be turned into a decimal, but I think that this is going to be our best solution, is just to say that I, that's the -1 part underneath that radical symbol, and square root of 1/2. And for problem C, I'd like to first take a look, because I do have a b value here, I want to first check and see if I know two numbers that multiply to 12 but sum to -7. So is there some set of numbers that multiply to 12? Well, -3 times -4 sum to +12, and they add up to -7. So factoring is going to be my easiest and quickest method, rather than doing all that work to do the quadratic formula. So we're going to say that x minus 3 and x minus 4 are the factors, and therefore if I set each of these equal to 0, I'm going to find out that my two solutions are going to be x equals 3 and x equals 4. All right, so when you go to do the two problems on the right-hand side of this page, I'd like you to verify to find out if it'd be easiest to use square roots, to use completing the square, to use quadratic formula, and of course you're going to refer to the front page to see which of these methods would be best for problem B and problem D. And now we're going to look at the real world problems, and we're going to use the quadratic formula to help us solve these. So if we have a juggler that tosses a ball into the air, and this is the equation that models the height of the ball in feet after t seconds. So t is going to make up the time, and h is going to be the height of the ball in feet. Okay, so suppose the juggler doesn't catch the ball. How long will it take for the ball to hit the ground? So let's rewrite this. 0 is going to be the height when the ball hits the ground. And if we're going to be using the quadratic formula, we need to identify our A, B, and C. Negative 16 is going to be A, 40 is going to be B, and C is going to be positive 4. And so now I just really need to plug in my information. So I'm going to say negative 40 plus or minus the square root of 40 squared minus 4 times negative 16, which is A, times 4, which is C, and then that goes over 2 times negative 16. And to simplify all of this, if I was using my calculator, I would say that, and remember we're solving for t, time, that is going to be equal to negative 40 plus or minus the square root of 1,856. That's what all of this simplifies down to. And that's going to be over negative 32, because 2 times negative 16 is negative 32. Now, because we're dealing with time, I'm going to go ahead and just take the square root of 1856 using my calculator. And the square root of 1856 using my calculator comes out to 43.08, which I'm going to round to the 43.1. Okay, so my two solutions are going to be t equals negative 40 plus or minus 43.1 over negative 32. Now, on the top, remember that's going to come out to two different results. So t is going to be equal to negative 40 plus 43.1 over negative 32, and t is going to be equal to negative 40 minus 43.1, and that's going to be over negative 32 as well. All right, so if we take a look at what's going to happen up here, this is going to result in a positive. So t would be equal to 3.1 on top over negative 32. Well, a negative amount of time doesn't really exist, so we can't consider that as a solution. However, we can say that t is going to equal negative 83.1 over negative 32, and the final number of seconds, or the final result in that, is going to be t. Let me just see if I can get this over here. Sorry, I'm making a mess of this page, but t is going to equal 2.6 when we make the division of 83.1 divided by 32. Remember, these two negative signs become positive because a negative divided by a negative is going to be positive. So we have our amount of time that it's going to take for the ball to hit the ground. On the final page of your notes, it's asking us to find out how long it takes for the ball to reach its maximum height, and we want to know what the maximum height is. So if you remember, if you throw a ball, it's going to take a path that looks kind of like this. Well, that is kind of like a parabola, a downward facing parabola. So how long is it going to take for the ball to hit that top height, where t and h are the values of that vertex point. So we need to find out how long it takes. We're looking for time. How long does it take to travel up this curve to reach its maximum height? And then also, what is the maximum height? If we recall from the previous page, A was equal to negative 16, B is equal to 40, and C is equal to 4. And what we need to do is we need to take our tool that we normally use to find the axis of symmetry, and that's going to give us our x value, which is actually our t value. All right, and so let's go ahead and see if we plug this information in. So I have t is equal to negative 40 over 2 times negative 16, and so t is going to equal negative 40 over negative 32, and I can reduce that so that t is equal to 1.25 seconds. 40 divided by 32 is 1.25. And now I know how long it takes for it to reach its maximum height, but now I need to find out what is its maximum height. So I'm going to take my t value and plug it back into the original equation. The original equation from the previous page was negative 16t squared plus 40t plus 4. So each time I see t, I need to plug in my amount of time, which is 1.25. So let's go ahead and do that. So we know that the height is going to be calculated by taking negative 16 times 1.25, and we're going to square that, plus 40 times 1.25 again, because that's where time appears again in our equation, plus 4. And when I do that, I use my calculator and plug it all in. The height is going to be 29 feet. Okay, for the example number 4, I would like you to try to solve this. Here's the equation, and it's talking about a baseball being hit by a batter, and the height of the baseball is going to be in y feet. And then the seconds, how many seconds after it's hit, is going to be in the letter t. So how long will it take for the ball to reach a height of 100 feet? Well, if the height is going to be in feet, that's going to be what you set y equal to. So I'm just going to give you a hint that 100 is going to equal negative 16t squared plus 96t plus 3. And I'd like you to use the quadratic formula to solve this. And we do have one more piece down here near the bottom. How long is it going to take for it to reach its maximum height, and then what is the maximum height? So I want you to go back and find out what we did for part B on example number 3 to solve that. So if you need to rewind the video and rewatch that part B, please go ahead and do that. So we will discuss example 4 in class, as well as the other examples that I've asked you to do here. If you have questions, please make sure you write those down so you can ask.